That's right. Today we're going to talk about similarity transformations. So similarity transformation is when you have transformations that take place. So examples like translations, rotations, reflections, and then also a dilation. So similarity transformations means that they're going to change size and orientation. So if you look at these two examples of similarity transformations, from the original shape, there was a turn, so there was a rotation, and a dilation. So again, similarity transformations always include a dilation. If you look at this next one, from the black figure to like the red-orange figure, it flipped over, so there was a reflection, and it changed size, so it was also a dilation. So it can either get bigger or smaller. The first one got bigger, the second one got smaller. It doesn't matter as long as it changes size. But if you notice, they always stay like the same. The figures, like the angles are going to stay the same. The sides are going to be proportional. So this will be like another example. There's a rotation and a dilation in that example. So doing points, with a composite transformation, remember this certain notation with that little circle, that tells you that you always do the second transformation first. So for this one, I would have to do the translation first. So if it's written like that, that means my XY rule would mean like I add 1 to the X and I subtract 2 from the Y. So we do that rule first to all 3 points. So 3 plus 1 is 4, 5 minus 2 is 3. Negative 1 plus 1 is 0, 4 minus 2 is 2. 1 plus 1 is 2, 7 minus 2 is 5. So we do that one first, and then you do the dilation. So this is a similarity transformation because there's a dilation in it. So that 2 tells me that the scale factor is 2, which means I multiply the x by 2, and I multiply the y by 2. So I just multiply all these numbers by 2. Get my final answer of 8, 6, 0, 4, 4, 10. So all I did was multiply all those numbers by 2 to get my final answer. Just remember, pay attention to the order. So you do the second one first. So this next one, first I do the 90-degree rotation. The rule for 90-degree rotation is negative yx. So I'm going to go back to my 3 original points at the top. And I'm going to apply that xy rule to those 3 points. So it would be negative 5, 3, the opposite of y, then x. The opposite of y is negative 4, x is negative 1. The opposite of y is negative 7, and 1. So I do that first. And then I do the dilation, which is this. So that tells me I multiply everything by 3, 3x, 3y. So my final answer would be negative 15, 9 if I multiply both those numbers by 3. Negative 12, negative 3, negative 21, 3. So that's how you apply similarity transformation to points. And if this was like on a graph, you would just graph those new points. That's it. Those are similarity transformations.